Hi, everybody. This is Mr. Folly, or I should say Hola, and this is podcast 11.3. A little bit early because some people are running off to Mexico, so I hope they are enjoying this, and I hope it's posted in time for them. We're going to look at the definition of entropy. We're going to learn when positive entropy is favored. We're going to look at qualitatively what's more entropic than the other ones. Hess's law, which again is products minus reactants. Gibbs free energy, Hess's law, or this is the other way to find this, and then charts of that. So let's hop right to it. Underlay. Entropy. Increasing entropy is favored by nature. So if nature favors increasing entropy, or increasing, remember it's disorder. So what would make a bigger mess? More particles or few? More would make a bigger mess. 1,000 pieces of Legos are harder to clean up than 10. Solids have less disorder than liquids, have less disorder than aqueous, have way less than gas. Gases are a huge mess. If I have an ice cube and I have to clean it up, or I have 10 milliliters of water and I have to clean it up, or 10 milliliters of salt water and I have to clean it up, or 10 milliliters of steam that escape and spread out throughout the whole room. Pick them all up. You can't do it. You can find entropy, which by the way is delta S, by using delta S. The reaction is products minus reactants. The units are joules per mole Kelvin, not kilojoules like the others. So I say S because I don't know what S really stands for. I say it stands for stupid unit because it gets annoying when you have to change from joules to kilojoules. So here's an example of it. Find delta S of the reaction. So delta S of the reaction is delta S of the reaction equals delta S products minus delta S reactants. So my products are HNO2. Oh, I need to see if it's balanced. Oh, look, they balanced it for me. Isn't that nice? So my products are HNO2, 46.1, plus HNO3, 53.5, minus bracket 2NO2, so 2 times 211, plus water, 69.9. If you remember when we did this before, we had a lot of negative numbers. And the reason why we can't have negative disorder is that remember, zero disorder is a perfect crystal at absolute zero, so you can't be any more ordered than that. So 46.1 plus 53.5 is 99.6 minus, and I like to do my distributions different, 2 times 2, 11, plus 69.9, 491.9. That would give me 99.6 minus 491.9, and I would get negative 392.3 joules per mole Kelvin. Now, if this is negative, that means that it should be more ordered on the right-hand side. This would be more ordered. And the reason why that makes sense is because, look, I've got gases. Gases are a mess. They're huge disorder. Huge, 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 huge. Little disorder compared to that. Why isn't S ever zero? Because we can't get to 0 Kelvin. We can't get to absolute, right? It's absolute 0. Absolute 0 Kelvin. It's too cold, and that's a perfect crystal, and we don't do that. Does state matter? Yes, the state of matter matters because gases have a huge impact. Gibbs free energy. This is just spontaneity for us. Okay, spontaneity is does it happen or not? Does it happen? It's calculated by this equation, delta G equals delta H minus T delta S. Stupid units, stupid units, stupid units. So make sure units work. Oh, look, welcome to another break in the podcast. So since I can't write anymore, I will just say toodles.